Hello everyone, welcome back to our channel. Today we'll solve one complex problem based on the centroid. So this is question number 10. You have not watched any other video, please go and watch the video to have the basic understanding of centroid. Now we'll try to break it down into easy steps. So for that we'll first draw the figure. We'll show all possible shapes here. So first shape is of semicircle. The next shape is this triangle. Then next shape is remaining triangle, and the next shape is this triangle. Now this big triangle will be subtracted from the total shape to get the required shape. At the end we have got this sector. This area is also considered in this area of total figure. So in this way we have got the first shape semicircle, then these two triangles, they are equal in shape, then the triangle, big triangle will be subtracted from the figure, and at the end we have got this sector. Sector starts from the origin and it goes up to this end. Okay. Now this distance or length is given 100 mm. The total diameter of the semicircle is given 30 mm. Then from this end to this point, the distance is given 10 mm on the two sides, right? So this is 30 plus 10, 40 mm in the upward direction, and this is a 40 mm. The diameter of this semicircle is 30 mm, so radius is equal to 15 mm. Now we'll find out the axis of symmetry. If you cut this figure in from the horizontal axis, right, from here, then we'll get the first shape, then the second shape. If you compare both the shapes, they are equal. It means your figure is symmetric about the horizontal axis. So no need to find out the y bar. We will only calculate x bar for this figure. Now we'll check if you cut it vertically, then it divided into first part and the second part. They does not match. It means it is not symmetric about the vertical axis. So x bar is not equal to 0. That need to be calculated. So we'll start with the semicircle. This is the given shape. We'll plot it on the graph. So this is your semicircle. The radius of semicircle is 15. So we'll find out the area. Now area of the semicircle is half of the area of circle. So pi r square divided by 2 is the formula for the area of semicircle. R is equal to 15. So we'll put the value and we'll get the value of area is equal to 353.429 mm square. Always write the unit. Now this is the centroidal axis for the semicircle. Now x bar will be this distance. This is the x bar. Now value of x bar is 4r by 3 pi. So put the value r is equal to 15, and remember it lie on the left side of the y axis. So that's why the left side of the x axis is negative. That's why a minus sign is put in the equation of x bar. The next shape is triangles. Now we'll consider triangle 1 and triangle 2 because both have the same dimensions. So this is triangle 1, this is triangle 2. Height of this triangle is 100 mm, it is given, and the base of the triangle is from this point to the x-axis, it is equal to 15. Total length is 30 mm given, so half of it will be 15 and half of it will be 15. Area formula is half base into height. So half into 15 into height is 100. Now remember it consists of two triangles. So we should multiply by 2 here. So half into base into height into number of triangles. Number of triangles are 2. That's why we get this equation as we know this 2 and 2 will get cancelled. So b into h. Now b value is say 15 and h value is 100. So we'll get 1500 mm square for this triangle. Now we'll find out the centroid for this triangle. Centroid is located here. So x bar will be distance from y axis to the centroidal vertical axis. So this is the value of x bar. Now this value is equal to 100 divided by 3. So it is 33.33 mm. So this part is slightly complex. Try to understand this. Both the triangles are considered to calculate the value of area and the x bar. Now the next shape is called as a sector. So this is the shape of the sector. Starting from the origin, it goes here, and then it comes back to the origin. So we'll plot it on the graph. This is the shape of the sector. To calculate the area of the sector, we should have the value of alpha. Alpha is the value half of the included angle and the radius r. We don't have the value of radius of the sector, but we have this vertical value. This height is equal to 15 plus 10, so 25 mm, and this length is equal to 100 mm. Now we can see a triangle located here. This is the triangle whose base is 100 mm. Now we'll find out this included angle alpha for this triangle. We know that base is 100 and height is 25, so we can use the tan relation. So tan theta or tan alpha is equal to 25 divided by 100. So alpha is equal to tan inverse of 25 by 100, and alpha value will be 14.036 degree. Now we'll find out the hypotenuse of this triangle. As per Pythagoras theorem, hypotenuse square is equal to addition of square of the remaining two sides, means 100 square plus 25 square. By solving this equation, we get r is equal to 103.078 mm. So in this way, we have calculated the value of alpha and r, which is required in the calculation of area of this sector and the x bar calculation. Now we'll find out the area. We have the value of alpha 14.036, r is equal to 103.078 mm. Now we have the formula of area of the sector. The area of the sector is equal to pi into alpha into r square divided by 180. The value of radius is 103.078. We'll put that value here and find out the area of sector. So this is the value of area of the sector. Now centroid. Centroid will lie somewhere here. So we'll find out the value of x bar. X bar will be equal to 2r sin alpha divided by 3 into alpha into pi by 180. Now the value of r is 103.078 into sine of 14.036. Put the value of alpha here and we'll get this value 68.033 mm. If you are still confused about the sector, we have prepared a very good video which will give you detailed understanding about the sector. So you can watch that video. We have calculated the value of area and the x bar for the sector. Now the last shape is triangle. Now we'll go to the fourth shape called as a triangle. Now this is the location of the triangle and this will be subtracted from the total figure. Now we'll first plot it on the graph. Now the height of this triangle is 100 mm and the base is equal to 30 plus 10 plus 10, so it is 50 mm. Now we'll find out the area. Minus sign represent it will be subtracted from the total area, so half base into height. So half into base is 50 and height is 100. So here we get minus 1 by 2 into 100 into 50. So the value is minus 2500. Now we will find out the centroidal point. Remember, it will be calculated from the base. So this distance will be equal to 100 by 3. But our x bar is calculated from the origin. That's why x bar should be equal to 100 minus 100 by 3. So this is the equation and we'll get the value of x bar is equal to 67.33. It is on the positive side of the x side. Now I'll put the values in the table format. First we'll start with the semicircle, triangles, sector and the triangles. Put the values of area and the x bar. Multiply them, put the value in the final column. So after doing this calculation, we are getting the value of x bar is equal to 28.88. So it can be calculated by dividing the summation of AIXI by the summation of area. Now y bar is equal to 0 because it is symmetric about the horizontal axis. So in this way we can break down a very complex problem into simple solution. If you find this video is useful, you can like this video and subscribe to this channel. Thank you very much.